Good morning 10th standard. This is the second part of the video based on exercise 4.3 statement questions. We have already done question number 4, 5, 6 and 7. Let us take a look at question number 8. A train travels 360 kilometers at a uniform speed. If the speed had been 5 kilometers per hour more, it would have taken 1 hour less for the same journey. Find the speed of the train. Let's start by assuming the speed of the train. This is question number 8. Let the speed of the train be x kilometers per hour. You have been given that the distance traveled by the train is 360 kilometers. So we have assumed the speed, the distance is given. Using these two, we can find out the time taken by the train. So time is given by distance over speed. This will be 360 by x hours. In the question, they are saying that the speed is changed. The speed is increased by 5 kilometers per hour, and that reduces the time taken. So we will refer to that as the new speed. New speed is x plus 5 kilometers per hour. The distance is still 360 kilometers. So using the new speed, we can find out the new time. This will be distance over speed, 360 over x plus 5 hours. In the second case, when they say that the speed is increased, the time is reduced. And it's mentioned in the question that when the speed is increased, the time is reduced by 1 hour. So that means this new time is 1 hour less than this original time. So according to question, new time equals to original time minus 1 hour. New time is 360 over x plus 5. Original time is 360 over x minus 1. So going over once again, you have been given that a train covers 360 kilometers with some speed. We assume that the speed is x. The distance covered is given as 360. Using the speed we assumed and the distance given in question, we calculated the time taken by the train as 360 by x hours. Later they say that some change is made. The speed is increased. So if the speed is increased, the time will be reduced. So speed is increased by 5 kilometers per hour. So the new speed is x plus 5. The distance still is 360 kilometers. Using the new speed and the distance, we calculate the new time. The new time will be 360 over the new speed, which is x plus 5. In the question, they are saying that the new time is now less. Because the speed was increased, the time will be less. If you want, you can write this, that the new time is 1 hour less than the original time. So this actually will help you to form the equation. So new time equals to 1 hour less means minus 1, and this will be subtracted from the original time. So using the values for the new time and the original time, minus 1, we get the equation. Simplifying, transposing minus 1 to left hand side and this fraction to the right hand side. I am taking 360 common from the right hand side. Taking the LCM in the brackets. Simplifying. X and X get cancelled. this is 1 equals to 360 multiplied by 5 over x square plus 5x. Cross multiplying, we get x square plus 5x equals to 1800. So my quadratic equation becomes x square plus 5x minus 1800 equals to 0. Splitting the middle term, from here I get two linear factors. Taking each of these equal to 0, I'll be able to find out x. So from this linear factor, x comes out to be minus 45, and from the second linear factor, x minus 40 equals to 0, x comes out to be 40. Since x represents speed of the train, it cannot be negative. So this value will be rejected, as the speed cannot be negative. So the answer is speed is 40 kilometers per hour. The next question that we have is question number 9. Two water taps together can fill a tank in 9 and 3/8 hours. The tap of larger diameter takes 10 hours less than the smaller one to fill the tank separately. Find the time in which each tap can separately fill the tank. Before we do this question, I would like you to refer to question number 2, second part of exercise 3.6. In exercise 3.6, question number 2, second part, we have discussed how we solve questions where we are given the time taken by a person to complete a particular task and what part of the work is done in 1 unit of time. Same concept will be used in this question. Let us take an example. Consider the example where a tap takes 5 hours to fill a tank. So if the tap takes complete 5 hours to fill the tank, that means in every hour some portion of the tank is filled up. So if we have to find out how much portion of the tank is filled in 5 hours, how do we find that out? So considering this, that a tap takes 5 hours to fill a tank, this means in each hour some part of the tank is filled up and we want to know how much part is filled in 1 hour. So part of tank filled in 1 hour. This will be given by a fraction because we are calculating part of a tank. So the total time will be in the denominator, and for 1 hour we will have 1 in the numerator. So 1/5 of the tank is filled up in 1 hour. So if we consider that the total time taken is 5 hours, that means the tank filled in 5 hours. So part of tank filled in 5 hours will be equal to 1 by 5 multiplied by 5. This will be equal to 1. If 1/5 portion of the tank is filled in 1 hour, then in 5 hours the whole tank will be completely filled up. So you can remember it this way, that if we have the total time taken by a tap to fill a tank and we want to find out how much portion of the tank is filled in 1 hour, this is how we do it. The total time in the denominator and in the numerator, because we are calculating for 1 hour, we will have 1 in the numerator. So you could write down a note for yourself before we start with the answer for this question. The concept used here is the same as in question number 2, second part of this exercise I'm referring to in chapter number 3, the work done by a person. If a tap or a pipe takes X hours to fill a tank, then some part of tank gets filled up every hour. Little by little the tank gets filled up. So we are assuming that the speed of the water is consistent. And from here we can find out how much part of the tank is filled in each hour. This will be total time in the denominator, and because we are calculating for 1 hour, the numerator will be 1. You could simply remember this, like if you know the total time taken and you want to find out how much work is done in 1 hour. The total time is X hours and we want to find out the time, we want to find out the work done in 1 hour. So this will be the answer, 1 by X. It's the reciprocal for the total time. Going back to our question, we've been given that there are 2 types of taps being used to fill the tank. The larger one takes 10 hours less. So let us start by assuming the time taken by the smaller tap to fill the tank. So let time taken by smaller tap to fill the tank be X hours. Therefore, the time taken by the larger tap to fill the tank will be X minus 10 hours, because the larger tap takes 10 hours less. Now based on this, we have the total time that the smaller tap takes to fill the tank, and we have the total time that the larger tap takes to fill the tank. We can find out how much part of the tank is filled by the smaller tap and the larger tap in 1 hour each. So from here we can find out part of tank filled up by the smaller tap in 1 hour. So for the smaller tap, the total time is X hours. We want to find for 1 hour. The fraction will be 1 by X. Similarly, for the larger tap, we have the total time and we want to find out how much portion is filled in 1 hour. So the total time will be in the denominator and we will have 1 in the numerator. Since these are fractions, there will be no units with these. Now we have the portion of the tank filled by the smaller tap in 1 hour and the portion of tank filled by the larger tap in 1 hour. So if we use both taps together, so how much part of tank will be filled by both taps in 1 hour? So some part will be filled by the smaller and some part will be filled by the larger tap. If we want to find out the portion filled by them together, we will add these. So this will be 1 over X plus 1 over X minus 10. Now let us consider what's given in the question. According to question, the total time taken by both taps to fill the tank is 9 and 3 by 8 hours. So this will be 75 by 8 hours. If this is the total time taken, then how much portion is filled in 1 hour? So just like this one, if we have the total time taken, we can find out how much portion is filled in 1 hour. Same way, we can use this to find out how much portion of the tank is filled by both taps in 1 hour. So part of tank filled up by both taps in 1 hour. This will be 1 over 75 by 8. The total time will be in the denominator and we are calculating for 1 hour. So the numerator will be 1. So this becomes 8 by 75. And this is again part, so this will not have any units. Now we have two results that we have obtained. This is the first result that we obtained here and this is the second result. This result was obtained by the values we assumed. We assumed that the smaller tap takes x hours in all and the larger tap takes x minus 10 hours in all if they are used to fill the tank separately. From here we calculated how much part they are filling in 1 hour each. Combining these, we can calculate how much part of the tank is filled by both taps in 1 hour. So this is what we get. This value is based on the assumed values. But according to question, this is the total time taken by the taps. If we use this value, then we can find out what part of the tank is filled by both taps in 1 hour. So this is the answer obtained if we use the time from the question. Since this expression and this expression both are representing the same thing, these two represent the same thing, part of tank filled up by both taps in 1 hour. These two must be equal and this is how we will form our quadratic equation. So what do we get from here? Therefore 1 over x plus 1 over x minus 10 equals to 8 over 75. We simplify this and obtain a quadratic equation. Let's take the LCM on this side. Multiplying the denominators. For the numerators we cross multiply. Let's simplify further. On simplification, the numerator is x minus 10 plus x over x square minus 10x equals to 8 by 75. On this side we have 2x minus 10, x square minus 10x equals to 8 by 75. Now we cross multiply. So 75 into 2x minus 10 equals to 8 into x square minus 10x. Simplify and obtain a quadratic equation. So taking all terms to one side, eight x square minus 230x minus plus 750 equals to 0. Taking 2 common from here, so when we transpose 2 from here to the right hand side, it will be 0 by 2, which is 0. So I am just ignoring 2. So this is the quadratic equation that I get. Now I have to solve this to find out the value of x. Now you can use factorization or you can use the quadratic formula. For this I'm going to use quadratic formula. And the first thing that I want to do is I want to write this in the standard form. Identify the coefficients. So comparing it with the standard form, A, B, C, the values are 4, minus 115, 375 respectively. This is the first step. The next step is to find out the discriminant given by B square minus 4AC. Use the values. So simplifying, we get 13,225 minus 6,000. This comes out to be 7,225. The next thing we want to do is we want to find out the roots. The roots actually give me the value of the variable. So that means we will be obtaining the values of x from here. So x will be given by minus b plus minus square root of d upon 2a using the values. Minus b is minus 115 plus minus under the root value of d is 7225. In the denominator it is 2 multiplied by 4. So this gives me 115 plus minus. Square root of this is 85 upon 8. Now from here I can obtain two values. So taking addition and subtraction one by one, 115 plus 85 by 8 and 115 minus 85 by 8. I get 200 by 8 and I get 30 by 8. Now simplifying, this cancels, this gives me 25, and from here we get 15 by 4. So there are two answers obtained for the variable x. Let us see what are the answers based on these two values. So if we take the first option, if x is 25, then the answer will be time taken by smaller tap. This was represented by x. So this means the time will be 25 hours. And the time taken by the larger tap, this was represented by x minus 10. So this will be 25 minus 10 equals to 15 hours. So if we use the first answer, this is the, if we use the first value, this is the answer that we obtain. Let us see what happens if we use the second value. So if x is 24, so if x is 15 by 4, if we use this, then what do we have? Time taken by smaller tap, this is 15 by 4 hours, which is completely fine. Now let us find the time taken by the larger tap. This is x minus 10. So if x is 15 by 4, the answer for this will be, taking the LCM, this is minus 25 by 4, which is not possible because this is the time taken. This value will be rejected. So the only answer possible here is this. The smaller tap takes 25 hours and the larger tap takes 15 hours.